Okay, here we're asked to solve a differential equation given an initial condition, so we can find a particular solution using that initial condition. And it's a differential equation that we're going to need to separate variables. And the reason you know that is because you have an x and a y on the right-hand side. So we need to separate variables first. That's very simple. If you have dy dx on the left-hand side, that means all the y's have to come to the left and the dx has to go to the right. That's just so you have dy and dx always have to be in numerators. So the process of separating the variables is this. Excuse me. I'm going to divide by y squared, and I'm going to multiply that dx on the other side. So now you're ready to solve this. Those are like mini differentials, so integrate both sides. The integral and the integral. Now the thing that makes separation of variables so important is now that we have all the y's and we're doing it with respect to y dy on one side and all the x's with respect to x on the right hand side. So the integral of y squared is, think of that as y to the negative 2. So add 1, it would be y to the negative 1, and then times a negative 1. So this is going to be negative 1 over y, because that was y to the negative 1. The integral of x is x squared times 1 half. And then we have plus c. That's the general solution. Now, normally when you see these like on an AP exam, they're going to say you need to put it in terms of y equals. So you can solve for c at any point you want. I guess I'll do it right now. So this initial condition is y of x equals 1. So y equals 1 when x equals 2. So here's the use of the initial condition. Y equals 1 when x equals 2. I'll be able to solve for c now. This would mean c equals negative 1. This would be 2, so minus 2. C equals negative 3. So when you plug c back in, make sure you don't do any more work on this. Once you get c equals negative 3, make sure you plug it into the equation you used to find it. Plus a negative 3 or minus 3. So now we're actually going to solve for y. So what I'm going to do is, because I don't want a complex fraction, and if this is a free response, you can have a complex fraction, but I'm going to assume this is a multiple choice, and I'm trying to pick the right value for y. So what I'm going to do first is get rid of my fractions. So I'm going to multiply everything by 2. The y I'm not going to worry about right now because that's what I'm solving for. But now I'm going to reciprocate both sides. You could do it with cross multiplication if you want, but probably just easier to reciprocate both sides. Now, the reason I waited until I multiplied by 2 was if I reciprocated sides right here, I would have a complex fraction because that 1 half would be as part of the bottom of this fraction. So that's it. That's why I did it that way. To solve for y, you would multiply both sides by negative 2. And there's your particular solution to the original differential equation. And that's that.